Okay, I'm Karthik Iyer. I've been with T-Mobile for 8 years as well. I'm a principal engineer. So I started working on ARO about a couple of years back when AT&T came to us and presented their application. So we have worked a lot with AT&T over the past 2 years in collaborating and building this app. We have also reached out to a lot of developers, making them understand the application and the wireless domain as well, because a lot of application developers don't think wireless. They think wireless as they don't understand the restrictions of wireless networks, and they don't necessarily develop application for wireless networks. So what we went and what we did was we worked with a couple of famous applications, and then we told them how you can optimize your applications for wireless networks. So this tool is made by AT&T Labs, and it's a diagnostic tool that helps benchmark your applications. For performance, it benchmarks against a set of defined tests. There are tests that the tool runs, and it'll give out results for those particular tests. And I'll go over those tests with you guys. So it's an application. It helps identify network inefficiencies and device inefficiencies as well. So it tests against both device and network. So in terms of battery utilization, network, radio resource utilization. So it has two components to it. There is a collector component and there is an analyzer component. So the collector component, it's an APK that you can install on the device, on your Android device. And now it's also available for iOS as well. But then the iOS piece, you have to be tethered to a Mac in order to use it. But the Android one is standalone. So it is used to capture device and application traces. So it does network traces as well. So if you don't have a real device, you can also use an emulator, Android emulator, and collect logs from that. Use that as your device. It also captures the video of the device as part of the test. So you can go back and see, you can play back your tests. And it also captures TCP/IP traffic for PCAP, as PCAP file. So you need a rooted device for this application. At least on Android, you need to have the device rooted. That's basically for TCP dump to take TCP traces. And for iOS, as I said, you have to be tethered to a Mac, and you have to be running the latest version of Android ARO 3.1, which can be downloaded from their developer site. So it's a good practice to go log into have a login to their developer site. They have a forum as well where you can post questions. So it's a pretty neat tool, useful tool. So the analyzer piece, it's a Java application that runs on the PC, and that can be downloaded from their site as well. So the collector itself collects the trace and stores it on the device memory, and you can load those traces onto the application for analysis. So as I said, it provides visibility into radio resource and energy utilization. You can play back the video of the trace. So it benchmarks against common best practice tests, which I'll show you. So what tests? So some of the tests that it loads is how good the device is on caching. Say your application has a bunch of predefined icons. Are those icons stored on the device? Are they being requested from the server every time you turn on your application? So those files may be a few kilobytes, but then they do generate a lot of network traffic. is how good the device handles connections. Do you ping the network every few times? Do you want to send analytics information, and do you keep pinging the network periodically? Or do you just combine all your analytic information and then send it at once while you're already sending other data? It also tests against the use of HTTP 1.0 usage, which is inefficient as compared to HTTP 2.0. From the trace, you can select a time when you want to analyze the app. Say, for example, you want to analyze 10 seconds worth of trace. So you can filter that out and see what the data consumption was and how your app behaved during that time. You can also filter out specific IPs pertaining to your app, or you can filter out other applications because the analyzer tool will when it's collecting traces, it'll have a bunch of applications. So you can filter out all those applications but yours and just analyze your application. So this was one of the tests that we did using the Words with Friends app. And as you can see, that app, it downloaded a bunch of duplicate objects. And then even though the amount of files were just 8, 10% of responses were duplicates. So it downloaded a bunch of icons, and then when you start the app again, it downloads them again. So it's using a lot of network traffic back and forth. When it could have cached those files, it's just 10 kilobytes. Just add it to your APK file when you're putting it, right? So does the network application, which had 2.6% of duplicate data. So in connection handling, so it's a test to see how often your app is pinging the network without any user input. So there is no user input. You just leave the app idle, and it'll keep pinging the network. So Words with Friends app had 22 such connections spread across the duration of the trace. And this will slow down your app and then not to mention it'll drain your battery as well. So if you have played Words with Friends, you would see that the app is really, it's a sucker of battery. Periodic connections is, so that's the test to see how often the app is pinging your network. So we saw that there was one connection that was going every 30 seconds. So, and then the device was so DCH state, if those of you know, DCH is a high power state which is a high data rate state as well. So if you want high data rates, you go on DCH. And that's a high battery consuming state as well. So the amount of data transferred was just 1 MB, but then it consumed about 500 joules of battery power, which is significantly high. TCP connection is, so there is another test that sees how efficiently the app is closing TCP connections. So if you don't close your TCP connection, if you're done, the server will send a ping to the device, and it'll ask you to close the connection. And that'll wake up the device, and that'll consume more battery. So we analyzed Netflix, and we saw that there was 7% of energy that was spent only on closing TCP connections. And the total time the device was on 8 seconds. That doesn't seem significant, but that's in terms of battery utilization, that's high. And again, it also gives you how much data rate your app is using. So for Netflix, we saw that it's using 550 kilobytes. That's the Netflix throughput, which you don't need such a high throughput for such a small device. Yeah.
In your second bullet point, when you said that the server pings back saying that It's telling the device to shut down the TCP connection, right? Which server I'm talking about?
Your application server.
Applications.
Correct, your application.
Basically, it's a two-way traffic.
Correct. Yeah, it's a two-way traffic. Yeah. So the server will send a ping saying that, what, close the TCP connection. Yep. Oh, any questions? I think that's, so these are some of the best practices an application developer can consider when building an app. So we put together a bunch of best practices. So when you're requesting data, do it asynchronously in parallel, so that when your page is loaded, and then if you have images, that gets loaded in parallel as well, so that your page download is not blocked due to the images. So save data and session information in case of failure, cache your data on the client as much as possible. When there is a network failure, you register with the OS to get that information, so that if the device is in a 2G, you don't keep requesting, because it's not going to help you if the device is in a low data rate technology. Lengthen your data burst, results in fewer transmissions. Queue up your background data and analytics. When the device is already in high state, that's when you can send your analytics information as well. You don't have to you don't have to wake up the device separately to send analytic information. Retry scheduling, check with network availability. If that is, don't keep retrying. Check if the device has network connectivity before pinging the server again. Using text compression, this is reducing the image size depending on the target. That is a good practice to do. Adaptive streaming, I think a lot of YouTube and Netflix use adaptive streaming now, depending on the network conditions and the device type. Compress text files, resize images to optimize for mobile device. Track the device orientation. This was interesting. So when you flip the device between landscape and portrait, the device would ping the network again. So this is a test that ARO does to make sure that the app doesn't ping the network on screen rotations. I think that's all my presentation. I'll just show you guys how the ARO tool works. I have a little demo. So you guys can see.
Yeah, 1 second.
So I have this ARO tool. So this is the ARO tool. So I can click on it. It needs super user access. So I'm going to kill all the other applications just to make sure. So go back and you can start collector. So it gives you a file name. You can rename this. And as I said, it records the video as well, but there are hardware limitations. Not every device would support that. For example, S4 does not support the hardware compatibility, and it would not record a video, this application. So it depends on the hardware. So now ARO is running in the background, and I can go and test my app. So I can turn on Netflix. By the way, this is AT&T, that's why it's slow. I'm kidding.
Who was our AT&T person that joined?
Say, for example, I play something. Let's play something PG. Family Guy, no. Yeah. Garfield. Hopefully that's PG. I'm going to let it play for like 10, 15 seconds here.
So I saw glitch there, right?
Glitch?
Glitch.
Oh, really?
I'm not sure I saw it. I mean, it's because of the recording or just happening on the phone. So the question actually is, will this affect the performance of the app itself?
No, it does not. So you're asking whether ARO contributes to the performance of the app here. No, it
Yeah.
does not.
Okay.
Yeah.
So is this just for Android, or you have like iOS?
Yeah, so for iOS, there is you have to be able to, it's not an on-device app. You have to be tethered to a Mac to use.
Yeah, that makes sense.
Yeah. Yeah, so I'm going to stop this. And I can go back and, oops, something happened. Stop collector. So as you say, I mean, it shows video failed to start, which means that it didn't record the video in this case. I'm going to have to do some setup. I'm going to have to transfer the files that are in there to my laptop and connect it.
Any questions while we're setting that up? I can bring the mic over to you and have a conversation.
So the app would tell me, how often I actually pinging the network, but is there any recommendation from various operators of how often an app should be pinging the network? Because at the end of the day, I can decide on, okay, I ping every 10 seconds and I'm good, right? Or should I ping every 30 seconds or 20?
Yeah, so you're asking about best practices for what to do after you analyze the data?
Yes.
So the tool will tell you what your network utilization is and what your ping times are and things like that. But Karthik, does it also tell you what, like, sort of what your duration should be, or when how much data you should wait before sending over a burst?
I'm sorry, what is it?
So we're asking, you get the information from the tool that tells you like how well performed your application is or how poorly it performs, but does it say you should change your application in this way to improve the performance?
Yeah, it does. It does. It'll tell you, it won't tell you how to do it. It'll tell you where to improve, what areas to improve.
So it won't say, for example, like you need to cache all of your data transmissions until every 10 minutes.
Correct.
And then send something.
It won't give you specific numbers, but it'll tell you, yeah, you could have cached it so that your app was wouldn't have downloaded duplicate content.
Okay.
Yeah.
But the issue for me is if I ping not frequent enough, then some of the network may decide that I'm on a zombie link here and they're going to cut me off anyway. Versus pinging sufficiently quickly so that I don't get cut off. And as an app developer, it's very hard for me to figure out what's the timer there. So
Yeah, I think that's the case, that it is difficult for an application developer to know what the network's going to do. So we need to be more sort of transparent.
It'll tell you trouble areas on what to focus on, but it won't tell you what exactly to change.
Yeah, so that's good feedback for this Meetup group in general, is for us to share with everyone what we consider to be a good measurement of performance for that, to give them a good idea of how to develop their application. Oh, question over here, sorry.
Question for Karthik. Today we have net neutrality, right? It's just a matter of time that we might lose that feature. might be 6 months, 1 year.
Correct.
So what do you see, or how do you visualize your tool being impacted because of this? Will you have to rewrite it for specific customer base or based on net neutrality?
So this is just a benchmarking tool. So I don't know how net neutrality would affect.
Because as time progresses, if I'm not a premium customer, then I might lose the bandwidth. I may not get the best bandwidth to have, right?
Correct.
So in that case, the tool might say my performance of the app is not good, but is it really the performance of the app or is it performance of the network?
Yeah, the tool has to be modified in that case.
Okay, so I thought so. Thank you.
Yeah. Yeah, so you would get both. Yeah, so yeah, so you would see both. So let me show you what it captures. Where did it go? Yeah. Well, it doesn't show here, right? Sorry, it doesn't show here. So there is a traffic.cap file that'll show you the network traces. So that's the tool itself. Yeah. So you can load your trace. I'm going to load the trace that I just captured.
So who mentioned that they saw a glitch when they were watching the demonstration?
I saw it.
Okay. Do
Two
you
glitches.
remember about what time that you saw it at?
10 seconds around.
Okay.
Okay.
So yeah, so the tool tells you what network it ran on, what is the device type, what version of Android it's using, what all applications were running when I captured the trace. So there was a Facebook going on. There's the tool itself, Netflix, of course. So there is something called as a profile. So if you're not on AT&T profile, so you can choose, if you are using Wi-Fi, you can choose a Wi-Fi profile. Because this is based off of a model, the calculations are based off a model. So you can choose the Wi-Fi and then your values would change. You can customize those as well, and you can have your own. So you can change, say you're on some other carrier, if you know those values, you can plug those in. So this is what AT&T uses. So
that's an answer for Antoine's question. Looks like he's not here.
he escaped.
Oh yeah, but you can set the different values based on what makes the most sense for that network, and then
Okay.
it will characterize it for your
For
network.
that network. Yeah. Was that his question?
Yeah, basically.
Okay. So yeah, so now it tells me that the app didn't compress the files correctly. So you can so these are the tests that the tool does. So these are the bunch of tests. So there are three main categories. There is file download, there is connection, and then there is use of HTML. And I think there's one more, peripherals. So how well your app uses either GPS or Bluetooth, whether it's using them without any need or just firing Bluetooth away or GPS away. So now it tells me that ARO detected that 5 kilobytes of text files could have been compressed. And it tells you where exactly those files are and what is the file size. For example, connection closing problems. So that was one of the tests that we ran. So for the most part, the Netflix application is pretty good, right? If you see. But then there are some areas where they can focus on. For example, 12% of the total energy was used in closing connections. So you can go over to the overview tab and it will tell you what the rate was. It's almost a meg, which is quite high. I mean, you do 1 megabytes. Do you need 1 megabytes for a smartphone? No. So that's too much data rate. I can come here and it'll show me the connection closing issues. So it'll tell me what closed, so who closed it. So there was a delay of 22 seconds. There was nothing going on for 22 seconds and the TCP connection was open. And it was closed by the server. The server initiated the close. And you can go pinpoint. I think if I double click, it'll take me to that point where that happened. So this tab shows me the traffic pattern of how Netflix application downloaded it. Anything that you see in black is basically a problem area where whether there was network retransmissions or packet delays. So you can see that the device is mostly on. So there were so many connections. So the bold yellows are the places where the device is in DCH state or high state. And the other ones are tails, whether it's a long DRX or short DRX. So if you can hover over and you can see that it'll tell you what the problem was. So the reds are traffic initiated by the client, and the grays are the long bursts. It also gives you statistics of how much, what the data rate was, how many packets was sent, what is the packet count, and what is the time that the device was on each state. And this is the caching performance. How much data the device actually cached and how much it requested. From what we tested 2 years back, the Netflix application has come a long way. We have given them a lot of feedback over the years, and looks like they're doing pretty good now. I can show you a trace that I took 2 years back, and I can compare that, and you can see the difference. All right. And it also has a waterfall view, which is pretty neat. It'll tell you on each instance how much the time to first byte was, so how much DNS time it took. So this is a pretty cool waterfall view of the whole trace. So it'll tell you how much each, so this took 372 milliseconds, which is quite high for DNS lookup in this case. And this is the part where I told you we can filter out applications that you don't need. So I can filter out Facebook and just keep Netflix app. So most of the traffic was due to Netflix in this case. And you can also see the battery state, how much percentage was when I started the trace. So it went from, say, 84% up to 82%, about 2%.
Does the ARO collector for iOS devices dump basically the same information?
It does. I haven't played with it. It just came out literally a week back. They just released it.
Are they planning or planning on collaborating with them to make the ARO collector for Windows Phone?
They're working on it. And I've been asking for it for a long time now, and they're working on it. Yeah. But then they want to focus more on Android because it's more open source and it's more you can develop better. It's more open. There are better tools available. Yeah.
All right. Well, thank you very much, sir.
Yeah, sure.